How do we write the terms of a sequence? Let's find out. Hi, I'm Dr. Finch, and I have over 20 years of experience in math education and a PhD in mathematics. Before we get into the problem for today too far, let's talk about what a sequence is and kind of review it. So coming down here, we see a sequence is an ordered list of numbers. So for example, we might see a sequence looking like 2, 4, 6, 8, and you can see that usually our lists, our sequences have a pattern. You can guess that the next term of this sequence is going to be 10. I say the word term because each number in a sequence is called a term. So we have those two different pieces of definitions that we need to know to work with this. Before we come back to our problem, I just want to highlight if you have a question or a subject that you'd like to have me explore, you can email me at purplefinchmath@gmail.com. All right, now that we know what a sequence and a term is, let's go back to our problem. We're writing the first four terms of the sequence starting with n is equal to 0. I'm going to actually write this out very slowly with a lot more words than you probably need yourself, but this way we can keep track of everything. Our first term, we said we wanted to start with n is equal to 0. So it's kind of weird. It's the first term, but n is equal to 0. In this case, everywhere we see an n in our little problem here, we are going to put in our number 0 that we're popping in. Okay, so we got -1 to the 0 plus 1, or -2 to the 0 plus 1. So this is -2 to the first power, which is -2. So our first term of our sequence is -2. Our second term, we are going to up our n value by 1. So now we're going to work with n is equal to 1. And again, everywhere we see highlighted in green, we're going to plug in the number 1. So we have a sub 1. Those subscripts there are used just so that we can follow along which term we're working with, which element of the sequence we're working with. That's all that they are there for. We get -2 quantity squared. Notice the parentheses are going to be important because without parentheses, we might actually end up still with a negative number. But if we write this out, you'll notice that we have two -2's that we're multiplying against each other, which means you have two negative signs. Double negatives, they cancel out. 2 times 2 gives us a 4. So the second term of our sequence is a positive 4. Now let's see what happens when we go to the third term. In this case, again, we're upping our n value by 1. So our n is now 2. 1 plus 1 is 2 on a good day. So everywhere we see the green, we plug in a 2. We have -2 to the third power. I'll write this out. So this is -2 times -2 times -2. Notice we have three negatives here, which means we still have a negative at the end. And 2 times 2 times 2 is 8. So we have -8. Now, if you feel uncomfortable with this, you can always rewrite this as -1 times 2 times -1 times 2 times -1 times 2, and then group the negative ones, which there are three of them, and group your 2's. Right, and that way we see we have -1 there, and we have 8 there, and we are multiplying, so we get -8. All right. So nice things to do. Practice that algebra without a calculator. Super important because you never know if your professor is going to give you or your teacher will give you a test without a calculator. Let's go to the next page for our fourth term so that we have a little bit more space here to work. Our fourth term and our last term that we are asked to find, we are going to plug in n is equal to 3. So we have a sub 3 is equal to negative 2 to the 3 plus 1. So this gives us negative 2 to the fourth power, which again, if we break that out, we have 4 copies of negative 2 multiplied together. You'll notice we have an even number of negative signs. When we have an even number of negative signs, our output is always going to be even. They cancel each other out. So this essentially gives us 2 to the fourth power, 2 times 2 times 2 times 2, which gives us 16. So the first 4 terms of our sequence that we are looking at are negative 2, comma 4, comma negative 8, comma 16, dot, dot, dot. You'll see there's a pattern here that we can kind of see already forming. Every other number will be negative, and then positive, negative, positive, negative, positive, and each time we multiply by a 2. It's very cute. Thank you for listening.